Okay, so let us discuss how a spring works in resisting deflection. Okay, so mostly ang widely used na tong mga support is the roller, the hinge, and the fixed. So what if natay spring, and how can we use superposition method or apply superposition method with beams nga naay spring? Okay, so say for example na kay cantilever beam with a uniformly distributed load nga W. Okay, so if walay resistance or walay support at the end, at the overhang, the beam will deflect at a distance. Let's say this distance here is y sub 1. Okay, so ang purpose na to nga magbutang ta og spring is to minimize the deflection. Pero again, ang spring has a different effect compared to other types of support because it could not support disregard, or it could not remove the entire deflection, no? Unlike the roller or the hinge nga pwede niya ma-minimize up to 0 ang deflection. So a spring, kita na magin mo na spring na siya'y compress siya at a certain length, pero nagyapon siya resistance tungod sa iyahang sa iyang pagka-homogeneous, no, sa iyahang rotation sa iyang material. So nagyapon siya resistance, so mo resist siya to minimize the deflection. Okay, so let us say nag-apply na kay spring. So kung na kay spring, ino na to kani na kay spring dire. So ano, pag-apply nimo sa load, instead nga moabot siya og y sub 1, ino na to nga mo deflect na lang siya at this point. Mo deflect na lang siya diri nga point because again, the spring resisted a certain portion of your deflection. Okay, so nigamay ang imuhang deflection. So kaning wala na resist nga kuan nga deflection, that is the spring's deformation from the length of the spring ni us-us siya. That is the deflection of the spring, in which deflection of the spring na to gamma s, deflection of the spring is directly proportional to the applied load. Okay, the deflection of the spring is directly proportional. Okay, so once you remove this one, the proportionality, balihon na kani, meaning ani kung na-increase sa load, napoy increase sa imuhang deformation or deflection. Ug mo decrease ang imuhang load applied, mo decrease pud ang imuhang deflection. Okay, so kanina lang kay para klaro. So if you remove this one, P is equal to natay constant. So deflection or deformation of the spring is P over K. Mo ni siya dere. Pero kani nabilin, that is the resistance offered by the spring, no? Ang nabilin, di ba, supposed to be ni us-us siya at up to kaning point, pero nisaka siya up to this point due to the spring. So this distance nga gisaka or gipugnan sa spring nga dili niya siya moabot aning y sub 1 nga kaubson, mao na siya ang resistance offered by the spring, which is concentrated, considered as a concentrated load. Ino na to og this is PL cube over 3 EI. Okay, concentrated load at the tip. Okay. So, with here, ma-equate na to, no? Nga y sub 1 is equal to the deflection, the deformation of the spring plus the resistance offered by the spring. Again, gamma S is the spring's deformation. So, ang akong terma na is the spring's weakness. Ako lang na kay ang spring man gyud nagi siya weakness compare gid nimo sa katong mga fixed roller o hinge. Nagi siya tendency nga us-us gid siya, dili gid siya full resistance. So plus this one, that is the resistance offered by the spring. So y sub 1 is equal to gamma S plus gamma. So y sub 1 is equal to P over K plus PL cube over 3 EI. Ano, equate lang nimo. The total deflection of a cantilever beam without any support is equal to the deflection of the spring plus the resistance offered by the spring. Okay, resistance offered plus deflection of the spring equal to total deflection without support.